Welcome to today's National Weather Briefing for the United States, with a special focus on Chicago, the broader synoptic pattern across the country, and extreme heat around the globe. In this episode, we'll walk through the latest forecast discussion style used by the National Weather Service office in Chicago and Romeoville, break down every complex term in plain language, and then zoom out to the large-scale heat dome, ring of firestorms, and global heat from the Persian Gulf all the way to India and Pakistan. Let's begin with the kind of upper air pattern meteorologists at the National Weather Service in Chicago and Romeoville often describe in their area forecast discussion. We're dealing with a strong ridge over the southern and central United States. A ridge is a bulge of higher pressure and warmer air in the middle and upper atmosphere, often associated with hot, calm weather at the surface. Along the northern edge of that ridge, small atmospheric disturbances ride the jet stream into the Great Lakes region. These disturbances are sometimes called short waves, and they help spark showers and thunderstorms. Under this pattern, Chicago tends to sit on the warm, humid side of the jet stream, with repeated chances for thunderstorms, some producing heavy rain, frequent lightning, and gusty winds. Daytime highs often run in the 80s to lower 90s, with muggy nights dropping only into the 70s. With dew points in the upper 60s to 70s, heat index values can climb above 100 degrees during the afternoon.
At times, a cold front sweeps through. A cold front is the leading edge of cooler, drier air pushing under and lifting the hot air ahead of it, which triggers showers and storms as that hot, moist air is forced upward. These fronts can briefly knock temperatures down and lower humidity, but in this kind of summer pattern, the heat and moisture often rebound within a day or two. Quick definitions in plain language. Ridge, an area of higher pressure aloft, favoring heat and generally quieter weather. Trough, the opposite of a ridge, a dip of lower pressure aloft, favoring clouds, showers, and storms. Cold front, a boundary where cooler, drier air pushes into hot, humid air, lifting it and triggering storms. Dew point is a measure of how much moisture is in the air. Higher dew points mean stickier, more oppressive conditions. Now let's zoom out to the synoptic, or big picture weather pattern across the entire country. Across the eastern United States, an extension of the central U.S. heat dome is producing above normal temperatures and sultry humidity. From the mid-Atlantic into the southeast, heat index values can reach the upper 90s to around 105 degrees, especially during the afternoon. The central U.S., the plains through the Mississippi Valley and the Midwest, sits under the core of the heat ridge. This is where the atmosphere is hottest and where the ring of firestorms are most active around the ridge's edge.
Out west, the pattern is more varied. Parts of the southwest can see hot, dry days under high pressure, while monsoon moisture builds over higher terrain in Arizona, New Mexico, Colorado, and surrounding areas, producing afternoon and evening thunderstorms. The Pacific Northwest and portions of the West Coast may experience cooler, cloudier spells as Pacific troughs brush through, bringing marine air and occasional rain. Across the northern tier, including the Dakotas, Minnesota, Wisconsin, and the Great Lakes, short waves ride the jet stream around the ridge. These disturbances trigger repeated lines or clusters of thunderstorms, occasionally severe, often racing east-southeast along the boundary between hot ridge air and cooler northern air. Along the Gulf Coast, deep moisture from the Gulf of Mexico keeps dew points sky high. That fuels daily storms, intense humidity, and heat index values that can feel far more oppressive than the actual air temperature. Now let's dig into the heat dome itself. A heat dome is a persistent, strong high-pressure area in the middle and upper atmosphere that traps hot air at the surface. Sinking air compresses and warms, skies stay mostly clear, and temperatures stay well above average for days or even weeks at a time. Under a heat dome, surface winds can be light, and the air becomes stagnant. This allows heat to build day after day, often producing extended heat waves.
Around the northern and eastern edges of this heat dome lies what meteorologists call the Ring of Fire. The Ring of Fire refers to the corridor where the jet stream and its disturbances travel around the ridged-up high pressure. Along this Ring of Fire, hot, humid surface air sits under pockets of cooler air aloft, creating the perfect environment for frequent thunderstorm development. Storms here can grow into large complexes, known as mesoscale convective systems, which can produce strong winds, heavy rain, and sometimes hail. Tornadoes can and do develop along the Ring of Fire when strong wind shear, abundant instability, and boundaries like fronts or outflow all intersect. This is not unusual. Tornadoes in midsummer along the Ring of Fire are a normal part of warm season severe weather climatology in the central and northern United States. Let's focus on a Midwest example. Continuous rounds of storms impacting Wisconsin and causing rain delays at baseball games in St. Louis and other cities along the boundary. Is that normal? Absolutely. When a strong ridge sits to the south and disturbances repeatedly ride its northern edge, storm systems can roll through the same areas day after day. New storms can redevelop on old outflow boundaries, leftover cool, dense air at the surface created by previous storms. This process is sometimes called training, when storms follow the same track repeatedly.
This kind of storm training and repeated thunderstorm complexes is a well-known climatologically normal feature of Midwest summers under our Ring of Fire pattern. So if games in St. Louis or Milwaukee keep getting delayed due to storms, it's very consistent with this kind of setup. Now let's talk about the Bermuda High. The Bermuda High is a semi-permanent area of high pressure over the western Atlantic Ocean. In summer, it strongly shapes weather across the eastern and central United States. When the Bermuda High extends westward, it helps pump warm, humid air from the Atlantic and the Gulf of Mexico into the eastern and central U.S. That air feeds both the heat dome over land and the thunderstorms that ride its edges. Together, the continental heat dome and the Bermuda High can lock in a pattern of heat, humidity, and repeated storms. They also influence tropical weather, guiding where tropical storms and hurricanes track. Let's talk about humidity and global heat. Dew points in the 70s are considered extreme. When temperatures climb into the 90s with dew points in the mid-70s, heat index values can reach dangerous levels, sometimes well over 100 degrees. That kind of heat can lead to heat-related illness without proper precautions. Regions currently experiencing very high dew points include the Gulf Coast, the Mississippi Valley, and portions of the Midwest, where warm Gulf moisture surges northward. Globally, South Asia continues to face record and near-record heat in many recent summers. Pakistan has seen temperatures reach the mid-40s Celsius, roughly 111 to 115 degrees Fahrenheit, under intense heat waves. India has experienced similar extremes, with dozens of heat-related fatalities reported during some of these events, as people struggle with both high temperatures and high humidity. In Iran and nearby countries along the Persian Gulf, summer temperatures often exceed 45 degrees Celsius during peak heat waves. The danger there is amplified by very warm ocean waters and high humidity. Now let's turn to ocean temperatures. The Persian Gulf is one of the warmest large bodies of water on Earth. During the hottest parts of summer, sea surface temperatures there can climb into the upper 80s to lower 90s degrees Fahrenheit, with isolated spots pushing even higher. When air moves over those extremely warm waters, it picks up tremendous amounts of moisture, leading to dew points so high that the heat index can become nearly unbearable for outdoor activity. The Caspian Sea, particularly its southern reaches near Iran, also warms in summer, averaging around 82 degrees Fahrenheit. That's noticeably cooler than the Persian Gulf, but it still contributes to regional humidity and can help support local storm activity. Closer to home, the Gulf of Mexico typically runs in the mid to upper 80s Fahrenheit in summer and can occasionally reach the low 90s in shallow coastal waters. These warm waters help fuel high dew points along the Gulf Coast, supply moisture for heavy rain events in the central and eastern U.S., and provide energy for tropical systems that may develop and move inland. So, to sum it all up, a robust heat dome across the central United States, fed by the Bermuda High and warm ocean waters, is driving extreme humidity, ring of fire thunderstorms, and occasional tornadoes along the northern edge of the ridge. At the same time, record and near-record heat in Pakistan, India, and the Persian Gulf region, combined with scorching ocean waters, is creating severe heat stress for millions of people worldwide. In patterns like this, it is crucial to stay hydrated, limit outdoor activity during peak afternoon heat, and pay close attention to local heat advisories, severe weather warnings, and air quality alerts. Thanks for joining us for this weather briefing. Stay safe in the heat, and we'll catch you on the next episode.